Hi, my name is Sage Pie, and I'm participating in the Challenge 2017, and I'll be speaking to you briefly about the unit circle. A unit circle has a radius of 1, the length from the origin, which is the center, to any point on the unit circle is the length of 1. There are 4 different coordinates in the unit circle. One unit to the right of the unit circle has a coordinate of x1, y0, without moving left or right, but 1 unit above the origin or the center. The coordinate would be x0, y1, as well as moving 1 unit to the left of the center of the unit circle would be x negative 1, y 0. And finally, 1 unit down from the center of the origin would be x 0, y negative 1. The unit circle can be used in both radians and degrees, so I drew a little unit circle for you. I don't know if you can see it, but we're going to work with it. So, here we go. Zoom, 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 zoom. Okay, so we have the origin or the center right here, and then to the right of that, you have 0, which is 0. Yeah, it starts at 0. I believe so. Yeah, starts at 0, and then you go up. Oh, and unit circles go from positive, which is counterclockwise, to negative, which is clockwise. So going counterclockwise, you go from 30 degrees to 45 degrees to 60 degrees. And then straight up and down on the y-axis, you have 90 degrees to 120 to 132, or 120, 135, I can't read my handwriting, my bad. To 135 to 150 to 180 to 210 to 225, 240, and then straight down it's 270, 300, 315, 330, and 360. So basically it's just a complete circle all the way around. And each that was in radians. So each radians has a corresponding angle. Oh, that was in degree. My bad. Each degree has this corresponding degree. Has this corresponding number in radians. So in radians, from going clockwise or counterclockwise, you have from 0, you have pi over 6, which correlates to 30. Then you have pi over 4, moving on to pi over 3, to pi over 2. So, and then you have 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, which is the halfway point, and then you go to 7 pi over 6, which is here, 2 pi over 4, 4 pi over 3, then you have 3 pi over 2, 5 pi over 3, 7 pi over 4, and 2 pi. I didn't write that one down. There you go. I got you. 2 pi. Okay, so there's a way that you can change radians into degrees easily. So let's say you take the angle 3 pi over 4. So you take, I don't know how to show you how I'm writing. So you take, I'll just show you again. 3 pi over 4 times 180 over pi. So you would cancel the pies out, and then you're left with 3 times 180, and this is how you get degree of 3 pi over 4. So yeah, you multiply 3 times 180 times 180 equals 540, and then you take 540 and you divide that by 4, because 4 is on the bottom in the denominator, and then you equal with 135, which is 135 degrees. My bad. So there's a way that you can do that in radians that you can flip it. So you take 45 degrees over 1 times pi over 180, and that equals, so you take 45 and you divide it by 180, equals 4.5, and then you multiply that by pi. Wait, no, hold on a second. I think you have to switch the calculator into radians. Mm, 45 divided by hold on a second. Okay, here 45 divided by 180 equals 0.25 times second pi. Okay, so the answer would end up being 45 times 180 equals 0.25, and then you divide that by pi, or multiply that by pi, and you equals 0.785. And that is your final answer. So, right here. So, 45, divide that by 180, times it by pi, and you equal this right here, 0.785. Thank you for watching my video.